Hello boys and girls, it's time for your first video lesson, and I'm hoping that this goes off without a hitch. What I'm going to talk about today are what is a matrix, adding and subtracting matrices, multiplying a matrix by a scalar, and properties of matrix operations. And here we have a little bit of math humor. You gotta love that. Little personification of matrices. So what is a matrix? A matrix is a rectangular arrangement of numbers in rows and columns. So let me draw you one. Here we have a matrix, and I'll just put some simple numbers in. 1, 2, 3, 5, 6, 7. The dimensions of the matrix are the number of rows by the number of columns. So this has 2 rows and 3 columns. So the dimensions are the 2 by 3 matrix. Each number in a matrix is called an element. So this is an element in the second row, third column. This is an element in the first row, second column. Now, if you're not a mathematician, the general idea of what a matrix is a 1999 movie, science fiction movie, with Keanu Reeves. So adding and subtracting matrices. In order to add or subtract matrices, they must have the same dimensions, meaning the matrices must have the same number of rows and the same number of columns. So if I had that first matrix, 5, 6, 7, this is a 2 by 3 matrix, and if I add to that another matrix, 4, 5, 6, 10, 11, 12, those are mushed together, that is also a 2 by 3 matrix. Therefore, I can add or subtract them together. So let's add these together. If I add it, what I want to do is I want to add the corresponding elements, meaning I add the 1 to the 4 because they're both in the first row, first column. So my resulting matrix would be 1 plus 4 is 5, 2 plus 5 is 7, 3 plus 6 is 9, 5 plus 10 is 15, 6 plus 11 is 17, and 7 plus 12 is 19. And looky here, our resulting matrix is also a 2 by 3. So that's an example of two matrices that you can add together. Similarly, I could subtract them. Now, if I had a 2 by 2 matrix, could I add it to a, whoops, I didn't mean to make that upper line, that is a matrix? No, let's erase that. Could I add that to a 1 by 2 matrix? No, because they do not have the same dimensions. This is a 2 by 2, this is a 1 by 2. Multiplying by a scalar. So let's remember that a scalar is simply a dimensionless number. And if I want to multiply a matrix by a scalar, what I need to do is just multiply each element by the number. So here's an example. I have 2 as my scalar, and this time I have a 3 by 2 matrix because it's 3 rows and 2 columns. So multiplying this together, I'm simply going to multiply this scalar by each element. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, and 2 times 6 is 12. Again, my resulting matrix has the same dimensions as my original matrix. It's a 3 by 2. Properties of matrix operations. Now you will have to think way back to Algebra 1 Part 1 for these properties, and I know you all loved them when you learned them the first time. So the associative property of addition. Basically what this says is A plus B, if I add those two together first, and then I add C, it's the same as adding B plus C and then adding A. So let me do a quick example. And I'm going to make this super easy. Ones and zeros. And then I'll throw in some two bigger numbers here. So that is the same as if I added, let me rewrite this, if I added the second matrices and then added the first one to it. That's a plus. I really, really like this stylus, by the way. Okay, so let's see here. If I add the first two together and then add the third to that result, it's the same as adding the second two and then adding the third to it. The commutative property of addition, meaning if I add matrix A to matrix B, that's a 0. That is the same as adding matrix B to matrix A. And if you don't believe me, go ahead and do the math. Distributive property of addition and subtraction. So if I do 2 times the sum of the matrices 2, 1, 1, 2 plus 0, 0, 2, 2, that's the same as doing 2 times the first matrix plus 2 times the second matrix. And it's the same deal with subtraction. So if that wasn't addition but it was subtraction, it would be the same deal. And just to make sure that you're still awake, is this the new roundabout sign in Jeff? Seriously, I especially like the good luck. I kind of feel that way on the way to school every morning. Okay, so I would like you to try a couple of practice problems just to see if you have the understanding of this. And I'll give you some easy ones. Let's see here. We'll do an addition one. 3, 0, 0, 5. Wow, I said that wrong. 3, 0, negative 5, negative 1, plus negative 1, 4, 2, 0. What does that equal? And number 2, I think I'm going to just like jump to a harder one for you because why not? Let's see, what if I was doing 3 times